Now we're heading to the Museum of Science and Medical, and also dedicated to Albert Michelson. Let's learn more about him. He was born on December 19, 1852, in Strelzeno, then part of the Kingdom of Prussia. His parents, Samuel Michelson, a merchant, and Rosalie Prisiluvska were part of a Jewish family that immigrated to the United States in the mid-1850s, amid political unrest and rising anti-Semitism in Europe. In 1856, Rosalie and the children traveled from Hamburg to New York to join Samuel. After a short stay, the family journeyed across the Isthmus of Panama and up the Pacific coast to San Francisco, eventually settling in the mining town of Murphys, California during the late 1850s gold rush era. In 1860, Samuel opened a dry goods store in town, where the family lived above the shop near the Murphys Hotel. At the time, the town was a gold rush mining center, populated mostly by miners, merchants, and tradespeople, and violence such as robberies and fights was common. As a boy, Albert helped in his father's store and studied with guidance from his mother. From his father, he developed an interest in mechanics, while his mother taught him classical literature and French, and arranged violin lessons. Music became a lifelong passion, and when Albert returned to Murphys in 1886, residents still remember his youthful love of the violin. With encouragement from his parents and teachers, Albert showed strong academic ability at an early age. By 12, he had exhausted the schooling available in town. So in 1864, his parents sent him to San Francisco for further education. He first attended Lincoln Grammar School and later the San Francisco Boys School. Impressed by his scientific talent, the principal invited him to live with his family, where Michael received tutoring, boxing lessons, and encouragement to continue practicing the violin. During summers, he returned home to Murphys. In 1867, as the economy declined in Murphys, the Michelson family moved to Virginia City, Nevada, a thriving center of the Comstock Lode. There, Samuel opened a successful dry goods and clothing store. Also, the family had grown to 6 children, including Albert, who continued his schooling in San Francisco while visiting his family in Virginia City when possible. As the mining boom declined, family members went their separate ways. By 1890, Samuel and Rosalie were living in San Francisco with 2 of their daughters. Rosalie died in 1892 and Samuel died in 1907. After graduating from high school in 1869, Albert competed to represent Nevada at the United States Naval Academy. Although he tied for first place, another student was chosen. His congressman then appealed to President Grant, who granted Albert a special appointment. At the Naval Academy in Maryland, Albert excelled in science, especially optics, and graduated at the top of his class. However, his creativity sometimes clashed with military discipline. During naval surveys, he was criticized for decorating his precise maps with drawings of local scenery. In 1875, Albert joined the faculty of the United States Naval Academy, teaching physics and chemistry. 2 years later, he performed his first experiments measuring the speed of light, improving a method developed by Jean-Léon Foucault and achieving results about 200 times more accurate than earlier measurements. His work quickly gained attention. The astronomer Simon Newcomb became his mentor, introducing him to leading scientists. Although Albert left the Academy in 1879, he retained its influence throughout his life, including a careful attention to appearance and formal manners. In 1877, he married Margaret Hemingway, and they had 3 children. His intense focus on scientific work and frequent absences strained their marriage, leading to their divorce in 1898. During this period, Albert conducted pioneering experiments measuring the speed of light. Using a rotated mirror system that reflected light between mirrors to calculate its velocity with remarkable precision. In 1899, he married Edna Stanton, a student at the University of Chicago. They had 3 daughters and enjoyed a more stable family life, with Albert spending time sailing and sharing his interests with his children. After measuring the speed of light, Albert sought to detect the luminiferous ether, which many scientists believe carried light through space. While studying in Europe, including at the University of Berlin, he designed the Michelson interferometer to test this idea. The instrument split a beam of light into 2 paths at right angles, reflected them back with mirrors, and compared their arrival times. Albert expected Earth's motion through the ether, but none appeared. In 1887, while director of physics at the Case School of Applied Science, Albert and Edward Morley repeated the experiment with greater precision. Again, no ether was detected. The Michelson-Morley Experiment later helped inspire Albert Einstein and his Theory of Relativity, which showed that speed of light is constant. Albert's design transformed scientific measurement and is still widely used today in physics, astronomy, engineering, and medicine, helping study microscopic structures, analyze light, observe distant galaxies, and even detect gravitational waves. In 1907, Albert received the Nobel Prize in Physics for his pioneering research on measuring and analyzing light. He was the first American scientist to win a Nobel Prize. During his career, Albert earned more than 15 medals, 12 honorary degrees, and recognition from major institutions such as the Yale University, University of Paris, and Princeton University. His work helped raise the international reputation of scientific research in the United States during a time when Europe dominated the field. From 1889 to 92, Albert led the physics department at Clark University, then founded the physics department at the University of Chicago, where he worked until 1929. In the 1890s, he developed a stellar interferometer to measure the size of stars and helped establish a precise distance using cadmium light waves and the meter. During World War I, Albert returned to the Navy and invented optical instruments such as rangefinders and improved binoculars. In the 1920s, using the telescope at Mount Wilson Observatory, he became the first to measure the size of a star. Betelgeuse, later experiments near Pasadena, California, refined his measurements of the speed of light. Albert was not only a brilliant physicist, but also a talented musician and artist. He played the violin, painted, and enjoyed activities such as billiards, tennis, and chess. sometimes even pausing classes at the University of Chicago for tennis matches. His artistic skill earned praise from Albert Einstein, who called him the artist in science. He spent most of his life devoted to laboratory work, finding his greatest satisfaction in experimentation. Though widely respected, he avoided public attention and preferred to share his achievements through scientific publications. In his later years, Albert faced declining health but continued working on a more precise measurement of the speed of light with colleagues Francis G. Pease and Fred Pearson. He died in Pasadena, California on May 9, 1931, at the age of 78, just days after dictating notes on the experiment. Albert A. Michelson regarded the Michelson interferometer as his greatest contribution. Although modern technologies like lasers have improved measurement methods, interferometers based on his design are still widely used today, reflecting his lasting legacy of precision in science. So that's it for the life of Albert Michelson. Until next time, to travel is to explore history. Don't forget to hit like, share, and subscribe. Bye! If you like our videos, please click thumbs up for like.
Hit the bell to subscribe!
Please comment.
And don't forget to share!